Hello and welcome to another edition of Ontology Talk. I'm Adam Pease, and today I want to talk more about graph representations following up a previous video that I did that I'll also link in the comments. So let's start with a simple example. It's an example from linguistics, author that I'm an admirer of named Terence Parsons. And so his examples are from antiquity here with Brutus stabbing Caesar. All right, so if you wanted to have a graph representation of this, you might have a node for Brutus, a node from Caesar, and a stabbed relationship between the two. This is a very common initial way to start defining these sorts of things. But there can be a challenge, so let me go into some of the possibilities and the pitfalls. So let's say we now want to modify that and say, well, how did Brutus stab Caesar? What did he use? He used a knife. And so you might come up with a representation like this that has a node, a knife, an instance of a knife, and that Brutus uses that knife to stab Caesar. And this looks fine until you start having other relationships with the entities involved. So let's say we have a relationship between Brutus and Brutus's mother. So Brutus's mother loves him. But now, what does this knife apply to? It applies to Brutus in some way. Does it apply to every relationship that Brutus has with other entities? Is there something bizarre and tragic going on here that Brutus loves his mother with a knife? Well, I certainly hope not. So how do we know that that attaches to the stabbing? Well, we don't. There's nothing from the graph that tells us that that's so. We might imagine it's so, but the graph alone doesn't capture that information. So how do we modify this graph to make sure that this using a knife essentially becomes a modifier on the stabbing action? Well, the way to do that is very similar to what we did in the last video I showed, that we use this technique called reification. So we name and create an instance of the relationship, and in this case that relationship is the stabbing. So we have an instance of a stabbing action, and then instead of having Brutus directly stabbing Caesar, a direct relationship between the two of them, we sort of promote this event and we give it its own node instead of having it be a relationship. We say that there's a stabbing node, and then there are a constellation of different relationships around that node. And those nodes and the relationships now can be named. We can say Brutus is the agent or the actor in the stabbing, Caesar's the victim, the knife is the instrument, the time is Tuesday, and so on. There are many other sorts of things that now we can say about this to capture all of the information that you might have in a common English sentence or any other language about an event. It could be any sort of different event. Now we've got a general method for capturing action sentences. So we can say Brutus stabbed Caesar with a knife on Tuesday, create this instance of a stabbing, and then talk about the agent, the victim, the instrument, and the time. And that captures the information in that sentence. But there's still some complications. There are other modifiers that may be a little more challenging. What if we want to say that Brutus didn't stab Caesar with a knife on Tuesday? How do we do that? Well, if we just have a didn't node or a not node, and we connect that with the stabbing, it's unclear what that actually means. Now, we can decide that it means one thing or another, but the key thing is that how do we keep that statement clear and consistent as we continue adding things to our graph? So let's take a look at that. So if Brutus didn't stab Caesar with a knife on Tuesday, but Polonius did the stabbing instead, and we just imagine a follow-up sentence, then what we're really saying is that the several aspects of this sentence and the relationships that we've encoded in the graph are true, but only one isn't. So there was a stabbing. It did happen on Tuesday. The instrument was a knife. Caesar was the victim, but the agent wasn't Brutus. Instead, it was Polonius. And this is pretty common. We shouldn't be restricted to just talking about positive statements in the world. The sentences that you and I and every other person uses to communicate with each other, negation is ubiquitous. We often have to talk about the things that we do not know, or the things we know that are not true, not just all the positive statements that we can make about the world. Negative statements are very important. So how do we capture them? So here's one example, right? So that it wasn't Brutus, it was Polonius. But another thing that we could imagine is a statement that said simply, Brutus didn't stab Caesar with a knife on Tuesday, nor did anyone else. Or how about, he didn't stab Caesar with a knife on Tuesday, he used a sword instead. That's another relationship, a negated relationship between a portion of this graph or a portion of the sentence and the stabbing. So here we could imagine another way, maybe to make this more specific, would be to create a negated relationship. So we might have not instrument, or not victim, not time, not agent, to signify that this is an anti-relationship, if you will, that the knife was not the instrument in the stabbing, but everything else is still true. Okay, that might work. It's certainly better, I think, than this notion of having a didn't node and attaching it to the knife. Of course, we still have the same problem. What happens if we want to say more things about that knife? Then we've just shifted the problem around a bit. We also might have a case like this. What if we don't know specifically whether the instrument used in the stabbing was a knife or a sword? We might possibly create an or node and then say that the instrument is the knife or the sword. Of course, this works again just for the individual nodes. What if we want to say a broader thing about either Brutus stabbed Caesar with a knife on Tuesday or he went to lunch with his mother on Saturday? We don't know which is true, one or the other. Now we're referring to something again with a bigger scope. And so in graphs, we always have this challenge that we really just have relationships between two things. We solved a small case of this in our last video for a ternary relation, a relation among three things, and came up with a way to encode that strictly in this binary relationship language. But this problem comes up again and again. And so if you're aware of it, then at least you have the chance to either tackle it in some kind of special case, as we've shown now with two different situations, or decide that maybe something else is needed. So I'm going to stop there for today, and I'll try to do a follow-up video on some other solutions for this. But for now, I hope I've made you aware of some of the challenges in graph representation, so that if you're trying to encode things of this sort, or things that are broadly similar, that you'll be able to recognize these problems and not do the simplistic encoding that would then leave you vulnerable to errors in reasoning and representation downstream. Thanks for watching this edition of Ontology Talk. If you found this video informative, please like, subscribe, and share, and check out ontologyportal.org, where there's a lot more information.